All right, let's try this question on the common ion effect, which you know because I've titled it that. But had you just come to this question, without that knowledge, how would you know that it's a common ion effect question? So let's read through what we've made in this question. So we're wondering about the concentration of HCOO minus, which is the formate anion. There's our 8 anion, okay? And we're looking at, and I could have written this out for you to make it a little bit more obvious, but that's formic acid, okay? And we've added some HBr. All right, so it's, in the solution, we put in some HCOOH. That looks like this, just to help get you more comfortable with these structures. That's the COOH, carboxylic acid functionality, and they're generally weak acids. And they end in ic acid, so that's formic acid. And we're asked about the formate anion. So once this is acted as an acid and it's lost its H plus, now it's HCOO minus, and that's the formate anion. Okay, so it's the conjugate base. So this is our acid, and here's the conjugate base. All right, so in solution, we're putting in HCOOH, and we're looking at this equilibrium as it dissociates into HCOOH and HCOO minus, okay? If this was just a weak acid question, like from the end of chapter 16, we would only have the formic acid in there. We'd have that 0.72 molar HCOOH. But now we're sort of turning the screw, we're adding in another layer of complexity. We've put in some HBr, okay? So we've put in some strong acid. Okay, that means that we have put in H plus and Br minus, and both of them will be at, and this should be molar, 0.06 molar. Okay, I know that I can ignore the bromide because it's the conjugate base of a strong acid, which means it doesn't react in solution. And so this is that we could pull that from our salt solution section from 16, where we say, hey, if your Cl minus, Br minus, I minus, NO3 minus, ClO3 minus, ClO4 minus, any of those conjugate bases of strong acids, we usually can ignore them as spectator ions. They don't react. The other thing is Br minus doesn't have a seat in this equilibrium. We can add Br minus all day long and it's not going to change the balance of these three things that we're interested in. But that H plus obviously does, because there it is. So we put in our initial concentrations of these things, right? We're saying like, this is what we're starting with. Now we need to find where does the system settle when it gets to equilibrium. We still need to make some products because I don't have any HCOO minus. So I've got to lose some HCOOH. I'm going to gain some H plus and some of this HCOO minus. And now I have these equilibrium expressions. I'm going to assume that this change in X is very small. Okay, we know that we have a small Ka value. We're not going to generate that much H plus, and we're not going to generate that much HCOO minus. So X is going to be small, which means that we can write 0.72 and 0.06. We're going to use our 5% assumption. So now I have equilibrium values that will plug into Ka, which we can write as 1.8 times 10 to the negative fourth. And that equals H plus times HCOO minus over HCOOH. All right. And again, this should look really familiar. We've been doing these kind of problems since chapter 15. And then we did in chapter 16, we did it exactly like this with weak acids, but now we have some of this. By that, I mean some of this, a really large amount of H plus. That is our common ion. Okay? It came from a strong electrolyte or strong acid. And that addition means that we are going to form more we're gonna have or we could form more HCOOH if it had not been added, or I could say a smaller percent ionization. All right, so let's plug our numbers in here. We've got X, sorry, I'll put in 0.06 first, X divided by 0.72, and we solve out for X, which is our formate anion concentration. And that's 0.0022 molar. Okay. So there's our answer right there. And I've been trying to go through some of the conceptual things that you might be asked about, like what's the common ion? Is percent ionization going to increase or decrease for our weak electrolyte? It decreases. Was there more? So like if I did this calculation again without adding HBr, I would have more than 0.0022 molar HCOO minus. Okay, because by adding this in, right, and then mathematically, like, look, this number is very big. We have to keep this constant. That the system goes to that K, right? So that means that this is going to be a smaller number than it was without that large sort of inflated H plus value, okay, that we got from putting in some strong acid.